Okay, hi everyone, and welcome to this webinar focusing on lighting in hospital and other healthcare environments. My name is Sofia Darling, and I will be moderating this webinar this afternoon. I work for the Nordic Center for Sustainable Healthcare as a member and community coordinator. Some of you may already know who we are and what we do, but for those who are new here, my colleague Felicia will soon give you a short introduction to who we are and what we do. Before we begin this webinar, I would like to go through some practical things. As you may see in the menu bar below, there is a chat function where you can write questions to the speakers. And if you have a question, please feel free to write it here. It is a good idea to post the question during the presentation so that the speaker can answer it right away when they're done with their presentation. So this webinar presents the third Nordic Know-How report on the topic of lighting and how lighting can be sustainable in hospitals and other healthcare buildings. Lighting can be both cost-saving and substantially reduce the environmental impact of a building, as well as create health benefits for patients and working staff. And as you can see with us today, we have 4 speakers who will tell you about their work. But before I present them, my colleague Felicia will give you an introduction of Nordic Center for Sustainable Healthcare. And my other colleague Johannes will talk a little bit about lighting to start this webinar. And I also just want to ask all the speakers to please make sure to have your microphones muted when someone else is presenting. Thank you very much. And I'll give the word to my colleague Felicia now. Thank you.
Thank you, Sofia. So, my name is Felicia Matz Wennerhed, and I work here at Stiftelsen or Nordic Center for Sustainable Healthcare. So for you listening today who are not really familiar with what we do, I'm going to do a short presentation about us. So, arranging the webinar today is Stiftelsen. And this is a non-profit foundation based in Malmö, Sweden. TM started as a project at Lund University already in the 80s and has since developed into a more independent organization that works with sustainability work at both private companies and public organizations. And TM manages 2 networks. The first is CSR Skåne, which is a regional network for here south in Sweden. The other one is Nordic Center for Sustainable Healthcare, which I'm going to tell you a bit more about in detail. So NCSH for short is, as I mentioned, a network which gathers a little bit more than 100 members. Including hospitals, regions, companies, universities, NGOs, and other kinds of organizations with a common goal, basically, to lower the environmental impact of the healthcare sector and increase sustainability performance. So our goal is basically to overall raise awareness, first of all, about sustainable healthcare, and from that create more innovations in this field, and also create an exchange of knowledge, best practices, and just information of what we do here in the Nordics and what is happening internationally in this field. So what do we mean when we speak about sustainable healthcare? We focus mainly on environmental sustainability in the healthcare sector, relating to healthcare operations, mainly building, facility, materials, technology, but also healthcare staff and inpatient treatment. Some examples are we work with energy efficiency, the use of renewable energy in healthcare, also nitrous oxide destruction, waste management, reduction of single-use items, and much more. We see sustainability in healthcare as horizontal rather than vertical. So it needs to be cross-sectoral and include a wide range of different sectors, such as food industry, clean tech, med tech, life sciences, architecture, etc., to have a holistic approach to sustainability. A little bit more concretely what we do, we create market opportunities and matchmaking for companies, and we spread information about best practices in hospitals. We manage a number of projects relating to sustainable healthcare. We also arrange a lot of activities such as conferences, international delegations, study visits at hospitals, networking activities, and trainings also in sustainable healthcare. So I'm going to tell you a little bit about Nordic Know-How, which is why we are doing this webinar today. Nordic Know-How is a report series that we are writing here at NCSH in collaboration with the Swedish Energy Agency, these first reports that we have done. Every report is written in English and has a specific focus on an area of sustainability relating to the healthcare sector. So our first report was on nitrous oxide destruction. Then the second was on geothermal energy in hospitals and other healthcare organizations. And today we're talking about the third report, which is on lighting. So the aim of this report series is very much aligned with our aim to create an exchange of knowledge internationally and just spread good practices and different things we're doing here in the Nordics in this field. Our next report this year, which is going to be the last one for the year, is ventilation, about sustainable ventilation in healthcare. We will have a webinar on this on the 20th of October if you're interested. Also check our website. On our website you can find the full Nordic Know-How reports and read them in their entirety. You can download them. Also check our calendar. You can see all of our events here. For example, our next webinar on ventilation. We also have an upcoming online seminar in collaboration with Yale University. So that's all from me. Thank you very much. I will now give the word to my colleague, Johannes.
Thank you, Felicia, for that introduction. Yeah, my name is Johannes Brundin, and I'm working here at TEM and Nordic Center for Sustainable Healthcare as a project manager. I will give the framework to this webinar and also relate lighting to sustainable healthcare. We're using this model to define sustainable healthcare. It was developed by Daniel Eriksson, who is the founder of Nordic Center for Sustainable Healthcare for many years ago. And we usually use cytostatica as an example, which is a very toxic substance which is used for treating cancer patients. And if this substance would have been used in the industry, it would have been banned many years ago because of its toxicity. It's very bad for the staff and it's very bad for the environment. But we are still using it in healthcare because it saves lives from cancer patients. So that way we need to find a way for the staff to handle this substance. And we also need to take care of the waste in a sustainable way. And in the end also raise the taxes to afford using it because it's very expensive. And we can also use this model for lighting. But when we look at lighting, this is usually where we start. We switch an old light bulb for a new one. And this, of course, it saves energy, it saves costs, and you need less maintenance because the lifespan is much longer. And we also get reduce the hazardous substances like a fluorescent light, which contains mercury. And the next step is then to add control. We can use presence sensors or daylight sensors or dimmers to use light when it's needed. This, of course, saves even more energy and extends the lifespan of the light source. The third point to look at is design and placement. We can, if we have the light in the right spot, lighting the right surfaces for the right tasks and so on, we can use less light, so we don't need as much lumen in the room, so to speak. LED do also have a smaller footprint, so it's easier to implement in new ways than traditional lighting. This can also, except for reducing energy, also improve the working environment. And then we do also have adaptive lighting. If we take a wardroom, for example, we have to perform different tasks. The doctor have to do examinations with a strong light to see the patient well, and then we also need the patient need to rest, and you need less light, and also the cleaning staff need to see all the corners to get a good result with cleaning. And we also have human-centric lighting, which is mimicking light through the day, so we have more yellow light in the evening and more blue in the day. And there are also studies on how this affects, like in night staff in a hospital, for example, and how it affects patients in a positive way to block the blue lights. And if we would have been talking about waste handling here today, then we would have mainly focusing on number 3 here, like sustainability, how we can prevent the waste to pollute the environment. But the waste system is not that related to the patient itself. He or she doesn't notice how the systems work in the background. And you can have the same approach for lighting as well. You can save CO2 and energy consumption just switching lights. But if we have a different focus point, if we instead focus on the patient, how we, with a good lighting environment, can shorten the recovery time, then we can treat more patients in the same space. And we can also increase the safety for the patient and prevent wrong faulty decisions from the staff. And this will triple down to the staff performance, and also like less stress on the staff, lowers the sick leave. And we can also lower the maintenance cost for the janitors who don't need to walk around in the same extent. And this has an economical perspective, but also a CO2 perspective. So we can, by having this focus on the patient, we can save much more CO2 than just focusing on the energy part. So that is what makes lighting very interesting and gives more dimensions to the sustainability perspective. Yeah, with that said, I would like to leave the word for Sofia, who will introduce the next speaker.
Okay, thank you very much, Johannes and Felicia, for starting off this webinar and for your presentations. It is now time for our first speaker, Anders Bru from Glamox. Anders will talk a bit about Glamox Guide to a Modern Lighting Design for Hospitals. Anders, feel free to start sharing your screen. Okay, there you go.
Thank you. Very good. Hello, and thank you for the opportunity to speak for you today. My name is, as Sofia said, Anders Bru, and I'm a concept manager for human-centric lighting in Glamox. And today I will talk about what's important to think about when you plan a light installation in a hospital building. And I'm not in Malmö together with the other ones. I'm at my office in Oslo. This is the outline of the presentation. First, we will have a look at what defines a good clean room luminaire. And second, we will have a look at how we use human-centric lighting and what we call biological lighting. I will define this later. And second, we will have a look at how we use human-centric lighting. Sorry, how we use the third part of human-centric lighting in our views, what we call therapeutic lighting. And also, at last, we will have a look at how we use colored lighting during surgery. And what is a good clean room luminary? What our clean room luminaires have in common is that they are all they have a robust design, and they are designed with easily cleanable surfaces, and they have excellent light output, and it's tested according to relevant demands, and of course all the other features that you expect from a modern luminary. There are many different applications in hospital. You have operation rooms, we have laboratories, we have bedrooms, we have psychiatric wards, we have industrial kitchens and more. And for this, we need the luminaires with different degrees of protection and specifications. And for instance, we need to fulfill the tough requirements for clean luminaires in operation theaters. And we also need a product with high impact degree and at the same time also easy cleanable surfaces for psychiatric wards. So we have to have a broad spectrum of luminaires to fulfill all the needs in such a complicated building. When you are choosing a clean room luminary, you should require tested products. And we in Glamox, we have chosen the Fraunhofer Institute for certification for our clean room luminaires. And for our series C64 and C65, it's been tested at the Fraunhofer Institute in Germany. Both of the luminaires are tested to ISO 14644/1. We have chosen the Fraunhofer Institute because they have more than 30 years experience in testing, and they have also the world's cleanest reference clean room. So their experience have been the reason for why we choose to test our luminaires at the Fraunhofer Institute. Both the C64 and C65 luminaires from Glamox are tested and certified according to ISO class 1. And when you have fulfilled ISO class 1 certification, all the different classes are fulfilled. These numbers here, this means that the luminaire releases less than 10 particles that are smaller than 0.1 microns. No larger particles are allowed. And to compare it, a human hair, as you can see here, is about 75 microns across. Another typical requirement for hospital buildings is the medical standard EN 60598-2/25, and this standards deals with special requirements for light fixtures, these requirements are especially aimed to mechanical strength and endurance. So we need additional certification to this EN certificate, which the Fraunhofer Institute can give. Our clean room luminaires are, of course, also compatible with all our light management systems. And as mentioned by Johannes earlier, with an LMS system, we're able to reduce energy costs additionally to get the correct light where you need it, when you need it. And an LMS system or a light management system also gives you a possibility to monitor your energy lights, and also you can get status on your lighting installation, and you can also report errors and so on. The Glamox luminaires are equipped with high quality LED modules. This means that they are more than twice as efficient as conventional light sources, which are installed across our country and across Europe in hospital buildings. Our LED luminaires also have a long product lifetime and creates less waste than conventional luminaires, since there are no fluorescent lamps or tubes that has to be replaced now with the new LED technology. If you see the major carbon footprint of a LED product is the service life during operation. So energy efficient product with a long lifetime reduces the carbon footprint of the luminary. Lifetime in hospitals is something that has to be taken into consideration. And in certain areas in a health institution, for instance, in the corridors, the light is on 24/7 all year round. And to give you an example, if you have a lifetime of 50,000 hours on the LED product, which can be said to be a branch standard, this is 5.6 years when the light is on all the time. And if you compare it with a lifetime of 100,000 hours, which can be chosen from several suppliers, it's 11.2 years. So this message goes out both to the planners of the building and also for the end users. And for the planners, it's about to give the good advice for your customers, and the owners of the building or the end users, they have to choose the right products that are cost efficient and cheap to own during their lifetime. Also, I want to mention efficiency in a LED product, and to illustrate it, we have here a light bulb, and we have the watt, which is the effect or energy used to light up the light source, and what comes out of the light source is lumen. And to have the system effect of a luminary, we have to have the connected watt and the lumen out, and this gives you the efficiency. Lumen slash watt is the efficiency of the luminary. And if you make the right choice, you can reduce your energy cost significantly. If I can take an example, if you have a recessed LED luminaire in the market, you can find it with an efficiency of 100 lumens per watt. And if you go for efficient product, you can see that it has 150 lumens per watt. So by making the right choice, you can save 50% energy before you have seen the energy savings from the light control system. So do the right choice and choose efficient products. That's very important. Okay, now I will go over and talk about human-centric lighting. And human-centric lighting is lighting solutions that can produce light of different colors, color temperatures, and intensity in order to provide ideal visual working conditions in challenging environments and stimulate the circadian rhythm. With HL, we put humans in center by developing lighting systems, and we have divided our HL solutions into three categories. We have biological lighting, ergonomic lighting, and therapeutic lighting. We will have a look at what this is now in the next slides. But first, we look back on biology and a new insight of the non-visual effect of light have received great attention in the recent years. And in 2017, the Nobel Prize in Medicine was awarded to a trio of, you see these three gentlemen from US. They got the Nobel Prize in Medicine for discovering the mechanism controlling their circadian rhythm. In other words, the 24-hour body clock. And what happens is that the light comes into our eyes and hits the retina, and on the retina we have the ganglion cells, and the ganglion cells, they send signals to the biological clock in our brain, and tells all the cells in our body that it's either day or night. And here we have a cross section of an eye, and we can see that the ganglion cells are on the retina. And these ganglion cells, they were discovered as late as in 2002. And the ganglion cells, they contain a protein, which is called melanopsin, which is sensitive to light with a wavelength of 480 nanometers. This slide shows the technical overview of the different technologies we are using in our HCl products. This might be details for someone, but I will go through it very fast. We have the tunable white solutions, which have one DALI address and have two channels. One with 2700 kelvins, LED modules with warm white light and cool white light, and we mix them together to get the different color temperatures. And we also have what we call blue box light, which has two DALI addresses, so this has to be noted when you are planning the light installation, and that's three channels, warm white and cool white LEDs, and also an amber diode, which we can produce blue block light with, which we use for therapeutic lighting, which I will talk about later. And we have what we call CCT-RGB, which is white LEDs with high color rendering over 90, and also colors. So we can use for colored light during surgeries. Biological lighting is very suitable for environments like hospitals. And here we can implement light cycles with the sunrise, sunset, and daylight simulation, as the residents often stay a longer period in these environments. The effects of the patient can result in higher activity levels during the daytime, better sleep at night, and also shorter recovery time. Therapeutic lighting is also what we call blue box light, and the development of blue box light is based on research done by using orange goggles in psychiatric hospitals. And Tone Henriksen, which is a PhD candidate at the University of Bergen, has done research within this field, and her research shows that people with bipolar disorder are sensitive to blue light, which is a lot of in ordinary daylight. And in her trial, 22 patients with mania got orange goggles from 18 o'clock in the evening to 8 o'clock the next morning for 1 week. And the control group received normal glasses. And after only 3 days, the patient's status was significantly improved. However, 7 out of the 22 participants, they would not wear the glasses. This indicates that the concept is very good, but it's not really possible for this target group. And the best solution would be to use blue block light as a part of the lighting installation. And a very exciting news is that Henriksen's study has gained international recognition and became a recommendation to a review study published in the medical journal Bipolar Disorder recently. And here they recommend the following. A dynamic LED light system can be installed in a hospital unit and be used to create blue depleted evening light environment similar to a virtual darkness. Indeed, a RCT to test the effectiveness of such an evening blue depleted light environment is underway in a psychiatric emergency ward. And this emergency ward is Østmarka Psychiatric Hospital in Trondheim, where Glamox has supplied the blue block light luminaires. And here we have a quote from Håvard Kallestad, which is a doctor at Østmarka, and he says the following: treatment with light and darkness affects the patient's circadian rhythm and has been shown to be effective, simple, and fast-acting. And not at least it's drug-free. And what we do is we have, as mentioned, luminaires with the property to give different color temperatures of white light and also amber light. And we do this in the same fixture. So it's one fixture in the wall, no, in the ceiling, sorry. Also, we also recommend to have daylight corners like this in the building where patients can seek to during dark winter times. And the daylight corners at the picture is from Østmarka. And here you can, if you sit in front of the luminaires, you get 8,000 lux on your eye. And this installation is fixed at 6,500 kelvins. A project where we have a delivered blue black light also have filters going down the windows, outside the windows in the evening time to block the blue wavelengths of the daylight. A study done at Østmarka Psychiatric Hospital has some interesting findings. The study with 12 healthy students slept 2 times 5 days in each department at Østmarka, one with normal light and one with blue block light, and the melatonin levels was measured every day. And the result is that when they lived under the blue block light conditions, they have an earlier release of melatonin. And now I will go very fast through what we call ergonomic lighting, where we use colored light to enhance the contrast on the monitors for surgeons doing endoscopic surgeries. We divide the room into different zones, and so we can have different colors on the wall. And the recommended color is to have green color in the direction of view of the surgeon, and have a red color as a contrast color behind. And we have white light over the patient. That's a very short words how we do it. And if you want to know more about this, you can contact us and we can help you. And this is a typical control panel, which can be equipped in the operation theater. Here's a quote from a happy customer. He says that with ergonomic lighting, the doctors have background lighting that is considerably more pleasant to work under, and thus they become less fatigued. This has tremendous significance in the case of long operations. This is what I wanted to say. I had to be very short at the end there to come through, but please, if you have any questions, I will have a look at the chat.
Okay, thank you very much, Anders. I can see that we have a few questions for you.
Yeah.
I think I will read them to you, and then you can answer them. So the first question is from Tilda, who says, are there any security issues that need to be addressed when installing a light LMS system? And does the daylight calibration vary depending on what latitude the hospital is located?
For security, the security issue, I would say that most LMS systems on the market today are safe in that degree. I would say it's tested and it's used for a decade, so that shouldn't be a problem. And when it comes to the impact of the daylight, of course, if it's if the hospital is situated in the Nordics, and especially long north in the Nordics, the savings will be greater in the winter time. Yeah.
Okay, thank you. We have also 2 questions from David. David Brasfield, he wonders, circadian lighting, I hope I pronounced that right, circadian lighting with customized light programs on a per patient level for hospitals will cost more and will therefore be difficult to prioritize over cheaper solutions. Can Glamox deliver cost-benefit analysis to support better investment decisions?
We can help to address the benefits from such an installation by looking at available research. We also hope that the studies that are underway also can help us to say that installation like this can lead to shorter recovery time for the patients. And if that's possible, then we definitely can help in the future. Yeah, and as mentioned, there is a study ongoing at the hospital in Norway at the moment, and the results should be ready very soon. And there we hope to see that blue bright light installation can lead to shorter recovery time for the patients.
Great, thank you. David also had another question, which is, do you have a link to documentation on the spectral distribution intensities of Glamox biological and therapeutic lighting products?
We can provide the spectral distribution of our solutions. Yeah, and he can get in touch, and we can help him.
Perfect. Okay. Another question. What is possible to do in an existing building versus new buildings?
Today we have a lot of new exciting solutions with the wireless technology and wireless lighting controls, which can give a lot of opportunities in existing buildings if these kinds of controls are welcome in a hospital. We have to see that what the customers require, but I think definitely in other sectors within health, I think that will be a solution that we can see a lot of in the future. And then you can use the infrastructure in the building and still have the benefits of the lighting control systems.
Okay, thank you very much for that. I actually think we have to move on to the next speaker now, but if you have any more questions, please feel free to write them in the chat, and maybe Anders can write his answer there. Or yeah.
I can do so.
Thank you very much, Anders, for your presentation. It was very interesting to hear more about you and your work. And it's now time for our second speaker, Christofer Silfvenius from the Swedish Energy Agency. Christofer, you're welcome to start sharing your screen, and you've done it already perfect.
Okay, thank you. I would like to thank also Anders Bro for a nice presentation, and I think it in some ways will connect to what we do at the Swedish Energy Agency. I work with testing of light sources and luminaires at the testing laboratory that is in Stockholm. So these first pictures show an overview of what we do. We are testing LED tube lifetimes. We are working with energy labeling. We are working with color quality together with performing arts like theaters and operas to define new sets of, to define how to define what is lighting quality. And we are also involved in looking at the definition of lumen due to the discovery of the sensors in the eye that Anders just mentioned. So when we look at what's going on in the lighting area today, it's a quite large revolution from the classical technologies. We have LEDs now entering almost every application for lighting. We are not application experts in my department, so we work specifically with product requirements. So it's always interesting for us to learn about how the products are used in different applications, like in hospitals, which is a very environment with special requirements from the users. The main trends for LED is, of course, increased efficiency. Still from year to year, we expect 5 to 10 years of a quite predictable road map up to 250, perhaps 300 lumens per watt. We also expect the cost to be reduced over the following years. Lighting has become digital from the classical discharge methods and incandescent wires. And we also see new business models where you don't really have to care about owning luminaires and light sources. You could just subscribe to have light in your office or factory or hospital and so on. Part of our vision, we have a vision for lighting, but part of that vision is that we will now leave the mercury-based lighting, move over to LED lighting, of course. And this will, just a few years ago, mercury-based lighting was perhaps the most efficient light source. LED lighting is now much more efficient than mercury-based lighting. The next step after switching to LED lighting is adding lighting control systems. So you can save quite a lot just replacing your T8 fluorescent tubes. We can also say that lighting is frequently forgotten in the building when you're looking at building energy systems, as you see from this typical schematic of a building and the energy systems. Lighting is not even included in that. And this is perhaps interesting, since the first product that you indeed connect as soon as you have electricity is lighting. But when you're planning for buildings, it's usually the last thing that is thought of, and you hang it up when the building is ready, sort of. A bit extreme to say like that, but it's sort of a observation that we have made. So in my department at the Swedish Energy Agency, we work with two regulations, that is 2 laws. One is called Eco Design, and that is a minimum energy efficiency requirement that is put on products. That that's the regulation that phased out the incandescent lamp in 2009. And if you only use that regulation, all the producers will adapt to that certain level, and you can see that here on the red, indicated with the red curve. So that's why we are using the energy labelings on products to attract consumers to buy the most energy efficient product. So that will shift the curve of the products on the market according to the blue line. Then we're also working with this a green line with other tools, and that could be research, financing, or procuring innovative solutions that did not exist before. So we have some news in this area. So from next year in 2021, there is a new energy label with a new scale. The new scale is from A to G, and it's quite ambitious. The top levels will be empty, ready for product innovation. And in fact, the most efficient lamp that we have ever measured is called, we call it the Dubai lamp. It's a sort of a product demonstration that Philips made actually a couple of years ago. It has a level of 200 lumens per watt. So it would be a B on this scale, but most products on the market today would be from C to F. So it's important to see then that the tops are, this is the third energy label for lighting that we have had. The innovation keeps moving, so we have to renew this energy labels. So that shows that this the system with eco design and energy labeling is working quite well. Major changes with this coming eco design regulation that is updated from September 1st in 2021. Oops. Should I hide that? I'm not sure. So compact fluorescent light sources with integrated drivers are phased out. T8 fluorescent tubes are phased out 2 years later, so in 2023. And this is the most common light source in Sweden, at least, probably everywhere. And I think it's very common in hospitals. Another news is that life testing method has been reduced in time, so from 6,000 hours to 3,600 hours. That includes a thermal cycle. So stress is also applied to the test objects. And we hope this will add the number of live tests that is actually performed, since before it was so long that was very little testing going on in that area. Perhaps of health interest is that there will be, for the first time, flicker level requirements, 2 new technical terms called PST and SVM for flickering measured when you look directly at the light source, and if you have light reflected from a rotating object, like a stroboscopic effect. So there are now levels that we can measure and have requirements on the product. So we think this is a great step for increasing lighting quality. When it comes to sustainability, there will be also requirements for repairability, reusability, and how to recycle the products. Already in place is a product database called EPREL that the manufacturers must enter data about their products. And this is searchable for consumers if they are looking for energy efficient products. There are lumen per watt requirements in this coming regulation. Let's see if we have a chat. Should I take it?
Christofer,
yeah.
I'm so sorry to interrupt, but could you switch to full screen maybe?
I have full screen. Where do I do that? Because I see only full screen.
Okay, because we can only see, yeah. Oh.
Is that one?
And if you press, if you go up, yeah, perfect, thank you.
Oh, sorry.
Okay, super.
Is this better?
Yeah, much better, thank you.
Yeah, I'm sorry about that. So there are lumen per watt requirements just in tables, as you see now on the screen. So the T8 you will recognize that it from September 1st, 2023, and then there is a lumen per watt level that it will be then impossible for this product to meet the requirement. So the product is not phased out in itself. There is a requirement that will be difficult for it to meet. So this is how this regulation works. So if someone is inventing a more efficient T8 tube, then it's will pass the requirement again. So you will find a number of common light sources, but just by looking into the table like this in the regulation. As we mentioned earlier, that it's possible to save a lot, and if you have an example looking at older mercury-based T8 tubes using the now quite old electromagnetic driver, you can save up to 70% by replacing it with a more modern LED based luminaire or LED tubes. And if you on top of that add control system, you will reach a total saving around 80 to 84% in total, and that is quite close to the sort of the vision we had in the beginning with a 90% energy saving. So there are a few different alternatives for replacing mercury-based light sources with LED. One is to replace it just with an integrated LED luminaire, or you could get a kit for the luminaire from the luminaire manufacturer to convert it for LED tubing, and then you will preserve the CE label, so you will not have any insurance issues. Or you could use retrofit tubes, and they should have the same power, weight, thermal properties, and that is sort of a bit difficult to exactly copy mercury-based tube with an LED tube. Or you could also use independent tubes. I think that is mostly what we see on the market today. But then the user or installer takes responsibility for modifying the luminaire. So in our laboratory, we have, due to the phase out, we anticipate a lot of questions about this, since this is a very common light source. You could say we purchased 17 products and 3 samples per product. And 6 of the products were intended for high frequency drivers, the more modern kind, and 9 of them for the older electromagnetic driver, and they were also connectable directly to 230 volts. And we also had a mercury-based product just as a reference. And we could see when it comes to energy savings that the tubes that were made for high frequency drivers on average had more than 62% higher lumen per watt value than the mercury-based tube. And they also all passed coming flicker requirements according to the SVM method, while the LED tubes sold for connecting directly to 230 volt had an average of more than 90% higher lumen per watt, higher than the mercury-based tube. But even if they saved more energy and they were more efficient, they had more difficulties in meeting the flicker requirement. But there were examples where you could both have energy savings and you could beat the coming flicker requirement. So in general, we could say that older luminaires absorbed about 25% of the flux if they had two dual tubes. But they also increased the maximum intensity with some 70% compared to just looking at the tube itself. So now we are aging these tubes that we have tested according to this new 3,600 hour cycle that will be introduced in the coming regulation next year. Just speaking about light quality, we are not only looking at the energy efficiency requirements. So in eco design, there are requirements on color temperature, color rendering, life length, and now also flicker requirements are common. But some areas, these requirements are not enough. So when you look at the light that you need on a theater performance or opera stage or perhaps a TV studio are much more articulate and much more defined. So we have financed a research project where theater scenes in Sweden are looking into this, how to define a new technical standard. So we can sort of understand each other's languages and use of light in different applications. When it comes to light and health, we could also think of that as a light quality. So we have worked together with the Lighting Research Center in Troy, New York for the last 10 years, and we invite them to Stockholm every year, and we give a seminar week, and we talk about lighting aspects. So you will all be welcome to join us at the Lighting Week in December this year. And this is also a Lighting Research Center who has come up with a suggestion to perhaps it's time to change the definition of lumen, because sometimes you get a discrepancy between what you measure in an installation and how you perceive it. And it can be explained with that if you had an update of the lumen curve that better matches how the eye is really connecting the light also into the brain, due to the new sensor that Anders also mentioned. I would like to share some planning ideas for our Lighting Week, our workshop. So if you would be interested to work closer with us, these are the themes that we are contemplating to discuss during this workshop week. And one is lighting during the pandemic. How is light used for this disinfection with the ultraviolet light, and how can you use daylight? How, when you work more from home, what do you need to think about? How much is your circadian rhythm disturbed when you're not leaving home in the morning, and so on? How is glare affecting you? That sort of issues. Another topic that came up that we are discussing now is sustainable lighting. So this workshop today is a great to see that there is an interest in this. The suggestion is then that we discuss life cycle analysis, life length issues. How do we repair? How do we recycle? Perhaps also advanced lighting controls, including Li-Fi. And Li-Fi is sort of Wi-Fi without Wi-Fi. You get internet connection directly via luminaires, and you can also get super local position information via the luminaire to your iPhone or iPad. So if you're lost in a very large hospital, you could get direction from the light source where you are standing. And then if we continue with topics that we are suggesting is like this theater scene that we looked at when minimum requirements are not enough. Performing art, light quality, lighting for museums, also health considerations, because when we work with the minimum requirement just on the product level as we do, we are not into the application, and health is a very interesting application for us to understand better how to work with when we are trying to formulate the regulation in our policy work. We are also working a lot with procurement, trying to understand how is the procurement system working, when does it not work, how can we help to improve it, so we really get all these products that already today are energy efficient, but we would like to see more of them installed and used. We are also involved in describing how we work with energy labels and the minimum requirements in other economies. So we are part of a UNIDO project. We are transferring what we know about energy labeling to 21 countries in Africa. So we see opportunities for companies to build up businesses in these countries and help to build a barrier so they are not a dumping ground for companies that don't have perhaps the best intentions at all times. And of course, planning for daylight to save energy is always an interesting topic for us. If you're interested in learning more about the Lighting Research Center, which we think is one of the best research institutes in the world when it comes to light and health, we have some recorded material with them that you can find on this link, and I will, of course, share the presentations with the participants of today. So, in summary, mercury-based T8 and T5s are no longer the most energy efficient alternative. We sometimes call it's too late for T8, but it's too late for mercury, we see. Energy-saving LED tubes with matching light distribution is available today. You don't need to worry too much that the light distribution will be an issue for you. Or, of course, you can switch to a LED with integrated luminaires. We really would like to encourage to make use of lighting designers to create comfortable and functional spaces when you plan your lighting. The next step, as we see it, and as you said, is to use also control systems. And you're all welcome to join us at the Lighting Week early in December and have a meet directly with Lighting Research Center. I guess everything will be online this year due to the pandemic. If you're into research, the ELYS, the Lighting Research Program, will preliminarily be open between November and March. So I think that's all I had to say. So
thank you very much, Christofer. We actually have to move on, but I think I can read. You have two questions in the chat. I can read one to you.
Yeah.
Maybe you can answer the other one in the chat.
Yep.
If that's okay. So the question is, second. Okay. Is the new energy scale for light sources or for system effect in a LED luminary, optics and driver included?
Yes, everything is included, and actually the word luminaire is not used since LED products can be integrated in a bookshelf and or table or almost any product. So it's a new structure, but most things will be considered light source or sort of a more general product, but then we must be able to remove the integrated part for controlling the energy efficiency. But it's the system in total that we are looking at.
Okay, thank you very much. There's a longer question as well, but yeah, perhaps you can answer this in the chat. Great, thank you. Okay, we have to move on to the third speaker for today. And Christofer, sorry, could you just stop sharing the screen maybe?
Yeah, where do I unshare?
Yeah, super, perfect. Okay, our next speaker is Stefan Westblom, who works for region Kalmar in Sweden. And he's here today to talk a bit about their lighting and work with energy efficiency. Okay, Stefan, feel free to start sharing your screen.
My name is Stefan Westblom and works at an region of Kalmar, and I work like an energy strategian there at the building company in the region. There we handle all the buildings for healthcare centers and hospitals for the whole region here. And the goal is to every year put down our energy consumption, of course. First, a little bit about our region, how to go to the next. It's located in southeast of Sweden on the coast to the Baltic Sea. And you see a little bit of facts here. As you see, winter temperatures, summer temperatures, about 7 degrees average temp of the year. And as I said, we are own about 200 building, totally 400,000 square meters, healthcare centers and hospitals. It's 3 hospitals through the county here. And we work a lot for energy efficiency, and lighting is of course one of those. And since like 4 to 5 years, we only put in LED systems, lighting system in our buildings. When we build new building and also when we do changes in the old buildings. And I will talk not just about lighting, I will describe you a little picture of all the things that we work in healthcare centers for this. So here's a list with what we do for putting down our energy consumption. And working with lighting and ventilation, we use IR sensors who knows if the room is occupied or not. And that's a very main thing for us to work with IR sensors who told us who people are in or out. And not just lighting, it also adjusts the ventilation flow and the climate. And we also have a thing that you must active push on your lighting in the room, but it will turn off automatically when you leave the room after a while. That's the main system we work with. And that's a very good system, we think. I'm counted here. We have about today like 50,000 square meters of building area who is all LED building and lighting systems. And like we're planning for at least another 50,000 square meters in the next 5 years when we should go over to LED. And have been measured that for a long time. You see it's very offensive to electric power. You see a little bit of performance here to get smart buildings with low consumption. Every building work with the design performance rules, how to make them. We had detailed demand of walls, roof, windows, insulation. That's the start to have a good building. Also fans is very important now to us to have low electric power to them. Recovery systems, speed controls of every electric motors for fans and pumps. And this performance document design we set up, we have a rule that the lighting should be max 8 watt per square meter installed power. And we have done that for at least half of this 50,000 square meters today. And the design level for a new building is about 50 kilowatt hour per square meter. Sorry. Must set off my phone, excuse me. So, and also we work with solar cell system on every new building. We put in a little bit of solar cells to produce our own electricity. I show you an example here for a new healthcare center, about 4,500 square meter, built in 2018. And it's built like for 50 kilowatts an hour for heating and electric power. And we use this Miljöbygg NAD level silver as a design set. And we have measured that now for year of 2019 and this year. And we see this, that the power total without heating is about 34 kilowatt hour per square meter a year. Of them, the power for facility, fans, cooling and pumps is like 21 kilowatt hour. So the power consumption for including lighting is about 23 then. Very low. And we see also that this building have a top power consumption of 55 kilowatts on a summer day with full cooling on. And that means we have about 12 watt per square meter. And the lighting design was 8 watt per square meter. So the users use about 4 watt per square meters for their equipment things then. Comparing to the average of all our region buildings, you can see we have electric power about 83 kilowatt hours. And I think it's about 50% who is connected to the building facilities there and 50% to the users. So there's a big difference to build a new designed building with this performance. Save us a lot of electric power. And the lighting is a good part of that, I would say. Yeah, for us, what's the issue to do successful energy efficiency? It's to have personal resources with competence and time allocated to the subject to work with these questions. And also have action plans for several years what we should work with. and norms for new buildings, design norms. And also when we get into older buildings, to have a startup budget to do changes for lightnings and put them to LED. And also, of course, following up the results of everything we do, monitor the energy goals before and after we have done changes in our buildings. Yeah. And the result, you can see a little bit here, how the electric power consumption have reduced. I have figures here from 2000 down to the year of 2019. And it's very nice to see this, putting down the consumption here for all our buildings. And it's the same for heating. We work a lot to reduce the heating too. But the focus have been on electric for the most. Yeah, here a little bit more facts, how much we consumption. 32,000 megawatts hour a year. For that, we also had a goal to set up and produce our own green energy with a windmill, who produce now about 30% a year. We also have solar panels producing like 300 megawatts a year. And you see the connections here, that the windmill is not connected directly to our buildings, unfortunately. We go to the net with it. But the solar panels, we have like 7 houses today with 250 kilowatts together power. And they produce right into the building that they sit on. And we don't sell any of that electricity to the net. Yeah, and here's another picture for our heating consumption, how we heat up our buildings. We work with district heating systems, like 98% of our buildings are heated in that way. The other 2% is local heat pumps. And some diagrams how our heating system is now. So I hadn't thought so much about talking about our lighting systems more than that we use this IR sensor system and like that. So if you have any questions, you're welcome to put on that. So I'm not prepared to show you any more of this, so please give me questions. I see, can I help you with lighting and healthcare?
Okay, thank you very much. We don't have a question in the chat, but I actually have a question for you.
Yeah.
And what would you say, in your opinion, what is the first step when improving energy efficiency in a hospital building? What is the first thing that you do? Do you have any recommendation there?
The first thing
in a hospital that has not done anything yet.
To set in a new ventilation system with fans and heating recovery. You save both of them though. Good efficiency for the fans and also put down the heating. So I start with that. And then after that, I go for changing the lighting system into LED. Yeah. So that's number 2.
Yeah.
Yeah.
Thank you very much. I can see that we have a question in chat now as well. And it's Daniel Eriksson who asks, have you seen a reduction of the cooling need when energy efficient lighting was installed?
Yeah, I have. Yeah, it's have a good effect of how much we have to cool out down our buildings too. Yes, of course. It's only 8 watt per square meters for the lightning. So yeah, we have very low costs for cooling our buildings.
Great, thank you. Do we have any more questions? I cannot see that we have one in the chat, but like I said before, if you come up with a question, you can just write it in the chat and maybe you can answer it there, Stefan. Yeah?
Yeah, thank you.
Yeah, thank you very much.
Bye-bye.
Bye. Okay, so it's time for our last speaker for today. We have Per Samuelsson with us from Hifab. Per is going to give us a presentation about their work with the new building at Eksjö Hospital. Per, feel free to start sharing your screen.
I'm on the line. Yes.
Great.
Thank you. I will share my screen now. I will talk a little about Eksjö Hospital, in a house in Eksjö Hospital called Hus 37, House 37, and it's newly built, and they have taken it in action in the spring. My role in this project has been to be the builders or developers controllant or inspector for electrical installations. The house is about 29,000 square meters, built in 7 levels. This is the hospital's face to the city, and there has been a lot of new localities for several units or departments. Builder is Regionfastigheter in region of Jönköping. Architect was White in Gothenburg, and lighting design Sweco Jönköping. Overall contractor was NCC, and the electrical contractor was Midrock Electric. In these 7 levels, there is a lot of different units. In the bottom, we have storage rooms and changing rooms, quite simple rooms. And then we have the morgue. Next level, we have some clinics and the big entrance, the big face to the city. Level 3, there is a lot of administrations localities, and as well as the department that sterilized the instruments for the operations units. And level 4 we have intensive care and 9 operation theaters in the operation unit. Level 5, then there is a big area that support all the operation theaters, as well as the orthopedic clinic with its administration is placed on the same level. And on level 6, there is care rooms, a lot of around I think it's about 30 rooms all in all to serve the patients who has to stay on the hospital. And at last, the technical area to support the rest of the house is placed on level 7. I will put some more spot on the high marked places in order to describe what the lighting solution was in these areas. First, in general, we have all the lighting fixture is LED fixtures and controlled by DALI, a control system, lighting system control system. We have in certain areas we activate the lighting with manual active on and out off function that you have to manually put the light on and a present detector that put out the light after a certain time. As well as there is areas that will be controlled by light relay or some areas automatic through time relays. The levels of the lighting is according to the standard 12464. Entrance as you see, there is a welcoming light to move to the face of the town, and there is a lot of uplit walkways, and the town, the area where the entrance is also very uplit, and the facade has some it's uplit, also uplit. The lighting is maneuvered with light relays and in some order to time. Yes, okay. We have the morgue, usually the area where the people work in the morgue is uplit as requested, and then we have the morgue has also a showroom for visitors to take farewell of their nearest, and it has been designed to be calm and peaceful, and will be accepted by all sorts of religions, and there will be nothing that stands out. In intensive care, we have a so-called circadian lighting that will follow the day rhythm of the light. It was a request to, it is an area there is a lot of all around the clock staff working, so it will be it will have an effect on their health. You could say health, yes. As you see, originally we had some white spots that we completed later on with that would follow the system as well. We didn't think initially that we had needed to have this in the toilet groups, but as well as on the nighttime, as well as in the daytime, it could be a very disturbing fact that it was uplit in these areas when you went in and out. In the operating theater, we have this ergonomic light that complete the white light in the loft top, loft roof, laminated area floor roof, airflow. In that area, the red marked area, there is a white light, and around that we have this ergonomic light, RGB, that will make the personal, the doctors and the nurses more. They wouldn't be like tired as in a normal lighting, and they will see the screens that support the doctors through the surgery, so they could see the screens of the data of patients and some X-rays, as well as some videos where you you have the camera that would go through the body. So they have tested this half a year now, and they were very, very pleased with the result. In the next slot here, we can see how they have used to. They have different scenarios. If the doctor is left-handed or right-handed, and if you have in which area you have to make the surgery, so you can make the green and red areas in these certain ways. They maneuver this lighting with two systems, one local system that is maneuvered by a PLC, and then they have a bigger integration system called operation system by Olympus. So this is the solutions of lighting in hus 37. And this was my contribution to this webinar.
Okay. Thank you very much for your presentation, Per. We can wait a few minutes and see if we have a question for you in chat, maybe.
Yes.
We have a couple of minutes before, yeah. We have a bit of time before we need to round off this webinar, so we can wait. In the meanwhile, I would like to say thank you to all the speakers for presenting here today. It was very interesting. And we have recorded this webinar, so it's possible to watch the presentations afterwards. Of course, if all the speakers accept this. So keep an eye on our website for updates about this. We have a question for you here from Christofer. How important was light quality in the project? Per, you're muted. Just a second.
Unmute. I have to unmute, of course. The quality was quite important in the areas where there was important work to be done, as in operation theaters and the sterilized departments, as well as all the overall in the areas where you treat the patients. It's really important to have a good quality.
Thank you. We have another question. The reduction of mistakes is hugely important. Do you know of good documentation on the economic and environmental savings from this avoidance of mistakes?
Mistakes. I have to be more. I would more specific. What mistakes? Is it the planning mistakes, or is it a mistake in the treatment, or yeah? So
perhaps it's possible to specify the question a bit. In the meantime, okay, now he wrote mistakes by medical personnel.
No, there is not a documentation of that, but if the doctors and the nurses have told my informant, the person that I work with, they told that they wouldn't be that tired as they were before. And it's a little bit difficult to compare, because the old areas where they did the surgeries was built in late 60s. So but they have been much healthier. There's not been a lot of sickness in 6 days, but there is no documentation, but it's a general feeling that the information I got.
Okay, thank you. We have a question for all the speakers. I think we have, maybe not all speakers are still here, but maybe those who are can answer the question. How do we share the knowledge from the hospitals and organizations with the rest of the community? So whoever wants to answer that question, go ahead.
I can maybe say something. It's Anders speaking from Glamox. I think that initiatives like this can help us, and of course we have to be out for our sake as a producer to talk to the end users and the decision makers to focus on these topics.
Thank you very much for that answer, Anders. Does anyone want to add something to that, or you think he said it all?
I have some. No, that was a very good answer to meet at workshops, and another way to work together and spread the information is to, as we see it, if someone applies for a research grant that is some part of the project includes distributing information, then we normally think that is quite a good project. So that is the ELYS research program that we are. It will be open now from November to March. So spreading information also via projects is my suggestion.
Thank you for your input, Christofer. Let's see. Thank you very much in this stage. I cannot see that we have any more questions. So I would take the time to thank all of the speakers for presenting here today. And also thank you to all the participants for listening in. And like I said before, I think this webinar will be available to watch online later. So keep an eye on our website for updates about this. And I also want to remind you about our next webinar on the topic of ventilation that we will arrange on October 20. And we will also publish that report before the webinar. So keep an eye on the website and in our calendar for this. Okay, thank you everyone. And thanks for joining us today. Bye.
Thank you, bye.
Thank you. Bye-bye.